Water covers 70% of our planet, which might make it seem like we have a lot of it. But the water we can actually use for drinking, bathing, and growing crops, freshwater, is quite rare. Only 3% of all the water on Earth is freshwater, and most of that is locked up in ice or not easily accessible for us to use. Did you know that almost 4 billion people, nearly 2/3 of the world's population, face severe water scarcity for at least 1 month every year? That's just the beginning. Over 2 billion individuals reside in countries where the water supply is inadequate. Shockingly, by as early as 2025, half of the world's population could be living in areas grappling with water scarcity. Moreover, some 700 million people might be forced to relocate due to intense water scarcity by 2030. The situation is dire, as by 2040, approximately 1 in 4 children globally will find themselves residing in regions experiencing extremely high water stress. These alarming statistics highlight the urgent need for action to address water scarcity on a global scale. So, what is the solution? Desalination. Since 70% of the Earth is covered in salty water, why don't we find ways to make it usable? And for this purpose, we can use the desalination technique. Desalination involves removing salt from seawater to make it suitable for drinking, irrigation, and other purposes. As freshwater sources become increasingly strained, desalination emerges as a potential solution to meet water demands, particularly in regions like the Middle East. Here, the water crisis is particularly severe due to rapid population growth and environmental challenges. Countries such as Qatar, Dubai, Egypt, and Saudi Arabia in the Middle East have turned to desalination as a primary means of addressing water scarcity. Despite its costliness and controversy, desalination remains a crucial strategy for mitigating the pressing water shortage in the region. Around the world, there are over 16,000 desalination plants. Some of the biggest and most well-known ones are located in the United Arab Emirates, Saudi Arabia, and Israel. Saudi Arabia stands out for having some of the largest desalination facilities globally. For example, both the Shuaibah and Al Jubail complexes can make more than 800 million liters of water every day. These plants use different techniques to remove salt from seawater. In Israel, the Sorek plant is the largest of its kind, using seawater reverse osmosis membranes. It produces up to 670,000 cubic meters of water per day and has achieved a record low water price, setting a new benchmark for seawater desalination costs worldwide. And Australia has about 270 desalination plants, mostly small-scale ones that clean seawater or brackish water. This water is used for various purposes, including drinking, industrial processes, sports ground irrigation, and agriculture. Major cities like Perth, Adelaide, Sydney, and the Gold Coast have larger desalination plants. Desalinating seawater is on the rise, providing about 60% of drinking water in some countries and meeting the 21st century's water needs. By 2015, desalinated water made up over 2% of total water consumption, with ongoing improvements in desalination technology through research and innovation. Well, desalination is not a new concept. People have known about desalination for a long time. Aristotle saw how the sun makes seawater evaporate into rain. Greek sailors boiled seawater to drink during their travels, and Romans used clay filters to take out salt from water. If desalination has been known for millennia, why aren't there desalination plants everywhere? Well, to understand this, let's start with the evolution of technology. The idea is actually quite simple. Take the salt out of the water. But in reality, it's quite challenging. Salt easily dissolves in water, forming strong bonds that are tough to break. So basically, there are two main types of desalination: thermal desalination and reverse osmosis. Thermal desalination is the earliest form of desalination, which involves a process similar to the natural water cycle. In this method, seawater is heated until it boils and turns into vapor. This water vapor is then collected and cooled, condensing back into liquid fresh water. The process effectively separates the salt and other impurities, which remain behind as the water turns to vapor. But as water has a high latent heat of vaporization, meaning it takes a significant amount of energy to convert liquid water into vapor. This energy demand makes the process very energy intensive. And typically, the energy needed for boiling the water comes from burning fossil fuels such as coal, oil, or natural gas. This reliance on fossil fuels makes thermal desalination expensive and contributes to greenhouse gas emissions, which are harmful to the environment. Plus, it produces a salty byproduct called brine, which is usually dumped back into the ocean. Because it's denser than seawater, it sinks to the ocean floor and creates spots with very high salt levels. These salty areas can harm marine life, as many sea creatures can't survive in such salty water. Additionally, the high salt and chemical content in the brine can reduce oxygen levels in the water, which further harms sea life. Now let's move to the second method of desalination: reverse osmosis. Reverse osmosis, or RO, became a popular desalination method in the late 20th century. It works by using a semi-permeable membrane to filter out salt and other impurities from seawater, leaving clean water behind. In this process, seawater is pumped at a slower speed just to protect the ocean life. Then it's filtered to remove things like algae and sand, leaving just water and salt. After that, the salt water goes through reverse osmosis, where it's pushed through a superfine membrane under high pressure. This pressure separates pure water from salty water. Some of the energy made during this process is used again to power the plant. For every 2 liters of salt water pumped, 1 liter of pure, demineralized water is made, and the other liter becomes brine, which is twice as salty. After being treated and made less salty, the brine is put back into the ocean. The pure water, with important mineral salts, goes into the drinking water system and gets to people's homes. Advances in membrane technology have made RO more efficient and less energy intensive compared to older thermal desalination methods. This means it uses less energy and is generally cheaper to operate. It also has a lower environmental impact because it doesn't rely as much on burning fossil fuels. Even though reverse osmosis is a big improvement, it still uses a lot of energy. For example, a facility in Kuwait uses more than 889 gigawatt hours every year just to clean water. Kuwait can afford this because it's rich from selling oil, but many other countries can't spend that much. It's clear that clean water is super important for everyone. As more people need water and some places run out, we have to find better ways to manage it. That means not just improving technologies like RO, but also making them use less energy and cause less harm to nature. So, there is another emerging new approach for desalination, and it's called solar thermal desalination. This technique uses solar energy to heat seawater, which reduces the need for fossil fuels. For instance, Neom City in Saudi Arabia plans to use this innovative method in its large-scale city project. The city will use renewable and sustainable technology throughout. That looks like this: a huge glass and steel dome rising 25 meters into the air, which covers a cauldron roughly of the same size. Seawater will flow into this dome, where it will be heated by mirrors that focus sunlight to turn the water into vapor. As the water vaporizes, it leaves the salt behind and then condenses back into fresh water. Since the facility is near the Red Sea, it can produce fresh water without using electricity or creating greenhouse gas emissions, except for the energy needed to pump the water. In addition, the plan involves extracting important materials like lithium, nickel, and cobalt from the leftover salty water, known as brine. These materials are essential for making batteries and other everyday technologies, and these valuable resources are in high demand worldwide. Currently, there are over 16,000 desalination plants operating in 177 countries. Together, they produce around 95 million cubic meters of fresh water every day. If you think about the fact that this water comes from salty seawater, which contains many minerals, it adds up to more than 100 million tons of seawater processed daily. This amount of seawater could potentially provide about 10 million kilograms of lithium every day. That's enough to make approximately 142,000 Tesla Model 3 cars daily. This idea shows that instead of considering brine as waste, Treating it as a valuable resource can encourage more desalination projects worldwide. This change in thinking could have a big impact on meeting the world's water needs while also helping manage resources sustainably. Will it change the future of the desalination industry? As solar thermal desalination has been an active area of research and development for some time, it has the potential to significantly change the future of the desalination industry. Solar thermal systems use the sun's energy, reducing the reliance on fossil fuels and lowering energy costs, which is a major factor in traditional desalination methods. Even by harnessing solar energy, these systems can make desalination more affordable, especially in regions with abundant sunlight. Through this process, less brine waste produces as compared to reverse osmosis, making it more environmentally friendly. This is particularly important for inland areas where brine disposal is a challenge. These systems can be scaled to meet different needs, from small, portable units for remote areas to large plants for urban water supplies. As climate change threatens freshwater supplies, solar thermal desalination offers a sustainable way to produce clean water, helping communities become more resilient to water shortages. Overall, solar thermal desalination could make clean water more accessible and affordable, driving innovation and growth in the desalination industry. While solar thermal desalination holds promise for sustainable water production, several critical questions still need to be answered. How can we make this technology more affordable and accessible worldwide? And what technological improvements are needed to make it more efficient? Additionally, how can we expand its reach beyond current regions? And finally, which research areas are critical to overcoming remaining challenges? Well, there are many more questions, but we'll have to wait and see how it all works out. We need urgent solutions. Waiting until clean drinking water becomes a luxury is not an option.